Morning, sir. Today our group will be presenting on the system we created in our distributed computer system subject. These are our group members: Adrian, Yu Yang, Guo Hao, me, Kushuchi, and Li Dingheng. Now I'm going to present about the background and history of smart home. The XM protocol, which permitted communication between the household gadgets and appliances across power lines, gave rise to the idea of smart home in the 1980s. However, the technique was not extensively embraced because of the technology restriction. Smart houses started to catch on with the advent of wireless connection in the 1990s. The first smart thermostat was released in 2011 and completely changed the business. The Nest thermostat was created to recognize the homeowner's preference and adjust the energy-saving temperature. For 2020 onwards, most people may now afford and have access to smart homes than ever before. For 2020 onwards, more people may now afford and have access to smart homes than ever before. The development of voice assistant like Amazon Alexa and Google Homes has made it simpler for homeowners to use voice command to operate the numerous pieces of equipment in their houses. The system of our project is Smart Energy Consumption Monitoring System. These are some of the background. The concept of our system is that the idea of monitoring power use was born with the advent of smart meters in the early 2000s. Smart meters allow utility company to monitor energy consumption remotely and bill the consumer based on the actual usage rather than the anticipated readings. These are the benefits that can be contributed by our system. Firstly, it provides the homeowners with a thorough overview of energy use, enabling them to pinpoint areas where they may save money. Secondly, it aids the homeowners in monitoring their advancement in achieving their energy-saving objectives. Homeowners may observe the effect of their activities and make necessary modification by tracking the energy use over time. Besides, homeowners may feel good about their environmental effect and lower their carbon footprint by using energy efficiently. According to the architecture diagram for data processing and data backup, we have implemented a Lambda to import the information from S3 to the DynamoDB. Well, for the alert system, we use back the same AWS Lambda. We send the information from the S3 to the user using the Amazon SNS. Besides, we also monitor our S3 using the CloudWatch alarm.
So, good day to sir. My name is Li Dingheng, and now I'm going to present the problem statement for our project. So, for our project, we have found some problems regarding the traditional electricity meters. Firstly, we found that they are quite obsolete because they are limited in their ability only to provide the cumulative electricity usage. So, what it does is it only records the electricity usage for each house. Besides, they also do not provide real-time data on energy usage because they are not connected to any network. So another problem is that these kind of meters that usually often require manual reading by the providers in order to get the electricity usage. So for example, we can see that for each month, the providers will send people to each house to record the energy usage. So in order to solve these kind of problems, our smart energy monitoring system can come into play. So here are the objectives for our system. So the first objective will be develop a system. The system will use AWS as a platform to monitor the energy consumption of the town. What it means is that so that we don't need people to go around each house and record the electricity usage maybe every month. So human cost can be saved. So secondly, AWS platform will be used to receive the data from the sensors. So these sensors will be installed in the electricity meter of each house. So after the data is been received, they will be displayed to the town management. Besides, this data also can be used to predict the future energy usage of the town. So the last objective will be the system, since they can get the data directly from the electricity meter, so they can generate a better visualization for the energy consumption for maybe different areas of the town. Yeah, so this is basically all of my part for now. Thank you.
So this is our architecture diagram for smart energy consumption system. So we'll be collecting data from buildings within an area through IoT core. Then it will be stored in Amazon S3. From Amazon S3, it will be sent to Amazon Forecast to predict future data of energy consumption, and then it will be stored back in S3. From there, we'll be using Amazon Athena to query the data in Amazon S3, and we'll be using QuickSight as our dashboard to visualize our data. And then we also have a backup where data from S3 will be stored also in DynamoDB. And lastly, we also have an alert system where we set a threshold for triggering. So if anything that will be sent, it will be triggered.
So now I will be presenting on how to connect to the AWS IoT core and how to send data from a physical device to the IoT core. So before we start to do anything, I want to mention that we have to create a thing in the IoT core in order for the physical IoT device to connect to the IoT core. So what a thing is actually a representation of a physical IoT device. What it means is that for each IoT thing, there will be an equivalent to a physical IoT device. So in this case, I'll be showing on creating a thing first. Then I'll use a thing. I will use my laptop as a physical IoT device to connect to the IoT core and send data. So now I'll be creating a new thing. So there are two important things that need to be configured when creating a new thing. First is the certificate, and another is the policy. So what a certificate does is like it's used to establish a connection between a physical IoT device and the IoT thing. And policy is like a predefined set of rules on the IoT thing, like what the thing can do and what the thing is not being able to do. So in this case, I'll be setting up the properties of a thing. For example, I'll be setting the name. So let's say I set the name as testing 001. So there are some additional configurations, but since they're optional, so I won't be touching them for now. So after inputting the name, and then I click next. So now I have to configure the certificate. So in this case, I'll be also auto-generating a new certificate first. So now I have to attach some policies to my certificate. So in this case, I'll be choosing this for now. So after I create the thing, okay, so the system will want us to download certificates and keys. So we noted that this can only be downloaded once. And this is quite important because we need to use these files to connect to connect our physical IoT device to the IoT core. So need to download them all first. So need to download the certificate, a public key and a private key file, and the CS certificate. Okay, so this need to download for now. So after downloaded, then we can click done. So we can see that our testing 001 has been created. So although I've created this new thing, but I won't be using it for the demo purpose because I've already created a new thing beforehand, just for demo purposes. So in this case, I've created a JavaScript code on how to on sending data, on simulate on how to send the data from a physical IoT device to the IoT core. So in this case, I'll be using my laptop as my physical IoT device. Just now I mentioned that we need those files to connect to the IoT things. So they'll be using here. So we are creating some sort of virtual device here with our private key, our certificate, and our CA path. So this host, this endpoint, can be found here. Under this tab, you can find settings here. Then in this setting, we can find our device data endpoint. So we just copy this endpoint and put it into our code. So after we have the information here, we can establish a connection to the IoT thing, the IoT core. So in my demo function, I'll be publishing, I'll be sending only one row of data to the IoT core. So before sending data to the IoT core, we need to do a pub sub thingy. So what we need to do is we need to subscribe to a topic first, and then we only can publish data to the topic after we have subscribed to the topic. So in this case, I'll be subscribing a topic called the house electricity demo. So I'll be publishing one row only. So by default, the IoT core can receive data from the IoT device at any time. But we can also use this MQTT test client here to visualize the record we have received. So in this case, I'll need to subscribe to a topic first. So just like I mentioned, our topic is the house electricity demo. So after I subscribe, here when there are any new messages, I can show it here. So currently there are no message. However, after I run this code, there should be a new record coming in IoT core. Yeah, so as you can see, after we have run the code will actually send a row of data from my laptop to the IoT core. So here will be the record of the data I sent just now. Yeah, so basically this is how connecting to how we connect to the IoT core using our physical devices. Yeah, thank you. Okay, so now I'll be presenting on how to redirect our IoT core data to the Amazon S3 bucket for storage. Okay, so it's actually quite simple. All we need to do is just to configure a message routing rule. So in this left-hand side panel here, you can see the message routing here, the message routing tab, and then the rules here. So we click on it. So as you can see here, rules allow our things to interact with other services. So in this case, I will be using the rule to send the IoT data to the S3 bucket. So now I will be creating a demo rule here. So firstly, we have to specify the properties of the rule, such as the name and the description. So in this case, I will set the name as demo, send to bucket. So the description, since it's optional, so I'll just omit it. So I click next. So this is the most important part because we have to choose which attributes from the IoT data we need to be stored in the S3 bucket. So in this case, the attributes I'll be selecting all attributes. So we put a star here. So the topic filter is actually the topic we're receiving the data. So in this case, I'll be using the house electricity demo. So what it does is any record from the house electricity demo, I will be selecting all of its attributes and store it into the S3 bucket. So the where is to filter the records you want and to filter the records you don't want. But in this case, I won't be using any condition filter, so I just put it blank. So after I've configured my SQL statement, you can just click on next. So as you can see here is the SQL statement. So next we have to define the rule actions. So what the rule action does is like after we have got the data from the data from the IoT core, what we need to do next. So in this case, we are going to send it into the S3 bucket. So I will add an action and I type on S3. So you can see that here is the action to store a message in the Amazon S3 bucket. So I just click on this So I have to define which bucket I'm going to use. In this case, I'm going to use in the home electricity bucket. So what the key does is is actually the file name. So in this case, I'll be just setting as demo house electricity. So we also need to define an IAM role here. So what an IAM role does is actually a role by attaching a role it allows you what can you do, what you cannot do. So in this case, I'm setting as the role as all privileges for demo purposes. So after we have configured this, we just click next. So after reviewing the rule properties and the SQL statement and the rule actions, so we can just create the rule here. So after create the rule, you have to make sure it is active so that it will redirect the message into the S3 bucket. So in this case, I will be running the demo file I've shown here, just the IoT core. So what the process will be is like when I send the data to the IoT core will redirect the same data into my S3 bucket and store it there. Okay. So now I will be going to the S3 bucket to wait for the data first. So just I've mentioned that I've stored in this bucket. Okay, so I will run this code to send a row of data to the IoT core. So we refresh on this bucket here. Okay, so just now we have named the file name as demo house electricity, right? So you can see that it's shown here. Now you can just open it here. So as you can see that the data we have sent from the IoT device is now stored in the S3 bucket as this format because we have selected all of these attributes. So we can see that these are the attributes that I have sent to the IoT core. And these are the attributes that I've received and stored in the S3 bucket. Since I'm using the select all from the topic here, so you can see that all attributes are saved in the S3 bucket. Yeah, so this is basically how to send an IoT core data to the S3 bucket for storing purposes. That's all for me. Thank you.
Firstly, for data backup, we need to create a DynamoDB that used to store the information. Firstly, we navigate to the dashboard. We click on the create table. We key in the table name and also the partition key. Partition key is the primary key. Then we leave all the setting by default. Then we click on create table. Next, we navigate to the AWS Lambda function module. We select the create function. We select author by scratch. We provide a name and a runtime. But here we choose Python 3.7 and also the architecture. Now for the role, we select create a new role with basic Lambda permission. Then we select create functions. There are 3 functions created. For the data backup, we created read from S3 and store in DynamoDB function. When we firstly created our function, we set S3 as a trigger. When there is any update information in the S3 bucket, it will trigger this function to update the same data to the DynamoDB for backup. In this Lambda, we are going to handle 2 tables. One is the energy usage, another one is the predicted data. Based on the code, firstly, we get the S3 bucket and the key for the CSV file. Next, we get the file extension from the object key. Then we check the file extension if it is CSV or JSON file. Different file type will have different operations. Since the CSV file is used to store the predicted data, while the JSON file is used to store the energy usage per month. For the CSV file, we read the file and pass it into a dictionary. Then we store the data into DynamoDB. These 4 lines is used to trigger the SNS to send a message to the user. The message will be new predicted value is updated. By this, the user may go to the dashboard, the QuickSight dashboard, to view the newly updated predicted data. Well, if the file extension in JSON, which is the monthly energy usage of the user, we read the JSON file and load it into a dictionary. Then we store the JSON into the DynamoDB. Then by here, if this condition and 4 lines of codes is used to trigger the SNS. In this condition, I set it as if the energy usage exceeds 2,100 units, it will trigger the SNS to send a message to the user, which is electricity use is how many units. Please be aware of the high energy electricity bill. Then after that, we save the function and we deploy it. To enable the sending of SNS in the function, we need to create a topic. First, we navigate to the SNS dashboard, then we click on the topic. Then you click create topic, you click standard, then you give your topic a name and all the settings leave by default, then you click on create topic. After you create a topic, you click on the name, you will see ARN. This ARN is important when we need to subscribe to our topic. To enable sending of SMS, you need to subscribe to the topic. First, you navigate to the SNS homepage, then you click on the subscription module, then you click on the create subscription. Here for the topic ARN, you need to copy the ARN from the topic summary and paste it here, then select the protocol. In this case, you select an SMS. Then for endpoint, you need to insert a phone mobile number that is functional to receive the SMS. Every new phone number added to the endpoint will require a verification process, which user need to input the combination of code that's sent to your devices. Then click on create subscription. To check whether the endpoint input by the user is functional, navigate to the mobile and text messaging SMS, scroll down until sandbox destination phone number. In this case, you can see the verified phone number along with the verification status. If the verification status is okay, means the phone number can be used to receive the messages. To allow our function to send SMS, we need to attach policy to the roles of the function. First, we navigate to the IAM page. We click on the role. We look for the role of our function. Click on the name. Then we choose add permission, attach policy. We search for the policy we wanted. Then we click on add permission. In this case, we need to assign Amazon SNS full access to the role. After we added, now the function can send out the messages. By completing these three configuration of the modules, we enable the data backup, which is insert of data to the DynamoDB, and the alert system, which use SNS to alert the users. An extra module that I include in our system is the CloudWatch alarm. The CloudWatch alarm is to monitor our S3 bucket. To configure the CloudWatch alarm, we need to create a new bucket to store the login, the access login. So firstly, we navigate to the S3 and bucket module. We create a bucket. We provide a name. Region. The region must be the same as other buckets such as Singapore, AP, Southeast 1. Then all setting list by default, you click on create bucket. After created our bucket, we need to allow the access login features on the bucket we want to monitor. We click on the home electricity bucket. We go to properties, scroll down. For server access login, click on edit, then you enable it. After that, we need to create a SNS topic to allow the sending of messages. Firstly, we go to SNS dashboard. We click on topic. We created a new topic, provide a name, then leave all the settings by default, then click on create topic. Then we go to subscription. Then we go to the subscription as the same as before when we create topic. We go to SNS dashboard, we click on subscription, then we click on the create subscription. For topic ARN, you go to the topic that you created just now for the access login. You copy the ARN from the summary, then we select the SMS as our protocol, then you provide an endpoint. Then you click on create submission. Same thing to check the status of our endpoint after we verified. You go to the mobile text messaging SMS, you scroll down until sandbox destination phone numbers. Then you will see the verified phone number and their verification status. After complete the configuration of the bucket and the topic, now we need to configure for the CloudWatch alarm to navigate our bucket. Firstly, you navigate to the CloudWatch dashboard, you click on alarm, all alarm, then you click on create alarm. Select metrics. Here we select the S3, which is the bucket we want to monitor on. Then you click on the storage. In here, you select on the raw, which is the home electricity bucket and the bucket size byte. Then you select the metrics. Here you need to provide, we set it as static, then your threshold, I make it into greater than 1 GB. Then you click on next. Let's say I put it as a random number, then you click on next. After that, we need to configure for the notification. First, you select the in alarm, then you select an existing SNS topic which is created just now, then you look for the name. And then for the endpoint, it will be the default endpoint that you verified just now, which is the phone number. Then you click on next, you will come here for a name and description. Then you provide a name, description is optional. Then you click next, preview your configuration in one page, then you click on create. After you created the alarm, the status will shown as not inefficient data. You need to wait for a while and the status will change to OK. By completing this CloudWatch, it will send a notification to the endpoint that we configured when the size of the S3 bucket is exceed by 1 GB. By completing all this configuration, now our system are able to backup the data into DynamoDB and notify the user about their electricity usage and also monitor the size of the S3 bucket. Thank you.
So I'll be doing the demo from Amazon Cognito to Amazon QuickSight. So first of all, you have to create a user pool. So you can put in the username, and for username requirements, you would like to allow it. Then you can leave all of these as usual. Then you can also leave all of these as default. And then then you should select send email with Cognito since this is just a demo. Then you can create a user pool. This is very important. So create a user pool, then host this UI, and this will be your domain name. So this is for your website when you want to log in. Then create a client name. So this can actually be the same as your user pool name. And so allow callback URL. You would like to allow callback URL. So in this demo, we'll be showing a embedded quick site, a user embedded quick site. So this one you would like to allow all, and this one correct. And this one you like to untick this authorization code grant and tick the implicit grant. Then for scopes, you would like to untick these two and tick for profile, and then put in the sign out URL. Then click next. And then once this is actually a page for you to review what you have configured, and then when you're done, create user pool. And once you're done, you can see it here. So we have already done the user pool, which is this QS dashboard embed sample. So here we have 3 users where we can create the user for our website. Then through app integration, you can actually see most of the things, and we'll be getting our callback URL here. Then we have API Gateway. API Gateway is used to connect to non-AWS applications to AWS backend resources. So we actually need it to invoke Lambda to getting QuickSight dashboard. So we actually have our own hosted UI for QuickSight. So first we have to create the API when we are selecting REST API. Then we can put any name we want. Okay, so we have done. We have created an API. So next we have to click on actions. We'll be creating a resource. So the resource you can actually name the same thing as you like. Then create. Then from resource we'll be creating a method, a get method. Then after that we'll be getting it from Lambda function. So I've already created a Lambda function, which is this, and we select all of these and then save. Okay. Then all you have to do is deploy the API. And yeah, since I've already deployed in one of the API, so that's why I can't deploy in this. So that's all. As you can see. As you can see here, I've already done the API gateway for the QuickSight dashboard. Then we also have a Lambda function to trigger the API gateway for the QS dashboard embed sample. So as you can see here, the Lambda is actually connected to the API gateway because it is used to get the QuickSight response when it is triggered. This code you can actually get it from the AWS workshop, which is a user embed QuickSight. So then after that, we'll be moving to IAM, because in IAM we have to set its role and policies of the Lambda so it can actually connect to QuickSight, because it requires permission to actually connect to QuickSight. As you can see here, QS dashboard embed sample policy, we have actually done it for QuickSight. So as you can see here, the action, QuickSight is able to search for dashboards, QuickSight register user, QuickSight create group. So these all are the functions that will be triggered on our hosted UI. Then I'll be showing you our demo for how Cognito can connect to QuickSight using our hosted UI. So first you'll be prompt when we enter our callback URL, we'll be prompt with username and password. So we just set our username and password. Since I already set it, so I can just input here. And then once you press login, you will see the loading screen, and you'll see embedded session view, embedded dashboard view, select dashboard. So here we can select our dashboards. So we have 2 dashboards, one is prediction and another one is monitoring screen. So as you can see here, we have done from Cognito to our own hosted UI of QuickSight dashboard. So with this, we don't actually have to go to QuickSight directly. Yeah, we just have to host it in our UI. So now I'll be talking about Amazon Athena. Amazon Athena is actually an interactive query service to make it easier for you to analyze the data. So I'll be doing a quick rundown on how to create a table from data source. So I'll be using S3 bucket, then give it a name for your table name. So for me, I'll put test. Since I have an existing database, I'll be using default as my database. Then this is the data set that you want. So for me, I'll be using house electricity. So I choose house electricity as the data that I want to query for my table. Then after that, the file format was JSON just now. Then we have to add the columns, the column name of your file. So in my file, I have plate number. Then I have property. I have area, and I have electricity. Then you have to select its column type. Once you have selected this column type, you can press create table and the table will be created. As you can see here, test, that is our table. So now we can write our SQL query like this and press run. And then as you can see here, we have actually successfully queried our data. And that's how you create a table in Amazon Athena. So next is Amazon QuickSight. So Amazon QuickSight we'll be using it to analyze our data. So first we have to press on new dataset, and then we have to create a dataset from our data source. So as previously we have actually used Athena. So give it a name. Athena will be used to query our data. So we select default because that is our database that which we have created the table in, and we'll be using tests. Okay, then after that, publish it. So it takes a while to load, so this is what it will look like when it's loaded. So we can actually filter the field list and then visualize the graph based on what field list that we want to set it. So that is all for visualization of using QuickSight.